Welcome to How Your Heart Beats, understanding the electrical system of the heart. In this short video, we will delve into the fascinating world of cardiology and explore the intricate workings of the heart's electrical system. Whether you're a medical student, a curious learner, or simply interested in the inner workings of your body, this video is for you. So let's get started. The central function of the heart is to contract rhythmically and pump blood to the lungs for oxygenation, and then to pump this oxygen-enriched blood into the general, systemic circulation. The signal for cardiac contraction is the spread of electrical currents through the heart muscle. These currents are produced both by pacemaker cells and specialized conduction tissue within the heart, and by the working heart muscle itself. Pacemaker cells are like tiny clocks that repetitively generate electrical stimuli. The other heart cells, both specialized conduction tissue and working heart muscle, are like cables that transmit these electrical signals. Normally, the signal for heartbeat initiation starts in the sinus or sinoatrial node. This node is located in the right atrium near the opening of the superior vena cava. The sinoatrial node is a small collection of specialized cells capable of automatically generating an electrical stimulus and functions as the normal pacemaker of the heart. From the sinus node, this stimulus spreads first through the right atrium and then into the left atrium. Electrical stimulation of the right and left atria signals the atria to contract and pump blood simultaneously through the tricuspid and mitral valves into the right and left ventricles. The electrical stimulus then reaches specialized conduction tissues in the atrioventricular or AV junction. The AV junction, which acts as an electrical relay connecting the atria and ventricles, is located at the base of the interatrial septum and extends into the interventricular septum. The upper, or proximal, part of the AV junction is the AV node. The lower, or distal, part of the AV junction is called the bundle of His. The bundle of His then divides into two main branches, the right bundle branch, which distributes the stimulus to the right ventricle, and the left bundle branch, which distributes the stimulus to the left ventricle. The electrical signal then spreads simultaneously down the left and right bundle branches into the ventricular myocardium, ventricular muscle, by way of specialized conducting cells called Purkinje fibers located in the subendocardial layer, or inside rim, of the ventricles. From the final branches of the Purkinje fibers, the electrical signal spreads through myocardial muscle toward the epicardium. The His bundle, its branches and their subdivisions are collectively known as the His-Purkinje system. Normally, the AV node and His-Purkinje system form the only electrical connection between the atria and the ventricles. Disruption of conduction over these structures will produce AV heart block. The ECG is capable of recording only relatively large currents produced by the massive working heart muscle. The much smaller amplitude signals generated by the sinus node and AV node are invisible with clinical recordings. Depolarization of the His bundle area can only be recorded from inside the heart during specialized cardiac electrophysiologic studies. So, you know how certain cells in the heart act as pacemakers by generating electrical impulses. It's kind of like tiny clocks inside the heart. Normally, the sinus node is the primary pacemaker, but sometimes other cells can act as backup pacemakers. This is actually a really important safety mechanism because it ensures that the heart keeps beating even if something goes wrong with the primary pacemaker. However, sometimes these backup pacemakers can become too active and interfere with the primary pacemaker, which can lead to abnormal heart rhythms. This can be dangerous and may even be life-threatening in some cases. Another important property of the heart is conductivity. This is how quickly the electrical impulses move through different parts of the heart. This is important because it ensures that the heart beats in a coordinated way. When things go wrong with the heart's electrical system, it can lead to all sorts of problems, from dizziness and fainting to more serious issues like heart failure. But understanding how the heart normally works is the first step in understanding these problems and how to treat them. Thank you for taking the time to learn with us today. Please share this video with your colleagues, subscribe to our channel, and give us a positive evaluation. Your support will help us continue to provide free, high-quality education to everyone who wants to learn.